everyone, my name is Scarlett, and today we're going to be talking about the D word, differentiation. I'm going to share with you my 3 favorite ways to differentiate a math word problem. Let's be real, there is no shortage out there of math resources, but do those resources really push your students to do their deepest thinking? Let's make sure we're all on the same page. What is differentiation? Is teaching the same material to all students using a variety of instructional strategies. With differentiation, we provide different paths for your students to reach the same goal. And it is allowing students to demonstrate their understanding in different ways. What is it not? It is not giving students different word problems. You're not just going to print out a few different worksheets, give it to different students, say it's differentiation, and call it a day. It is not giving students easy work because you don't think that they can complete the same work as their peers. You should be giving students all the same work. And right now we're talking about students in a general education classroom or students with an IEP that don't have curriculum modifications. It is not grouping students based on their last summative assessment score. Now, there are ways that you can do this, but I know that in my experience, I have heard that if I take my last unit test, group the kids, these are my low ones, these are my high ones, these are my middle ones, that's differentiation. Well, guess what? The things you covered on that last unit test might not be relevant to what you're learning now. So don't hold students back based on a score that they got previously. So let's talk about our 3 ways. This is option 1. Add pictures. Maxine is making a model windmill for a science fair. She is connecting 4 cardboard tubes together vertically. Each tube is 28/100ths of a meter in length. What is the combined measure of the connected tubes? So this word problem actually comes with a picture to the right. I showed this to my students, and after we were working for a little bit, I thought I'd ask them, do you know what a windmill is? And they had no idea. So let's add some pictures. You can show a windmill in a field. You can add a picture of a windmill in the word problem. And also, do they know what vertically is? You can show them a number line and say that that's vertical. You can show them exactly how those 4 cardboard tubes are going to be stacked. That way the students know exactly what the question is asking. We're not here to trick them. We need to make sure that they know what the problem is asking them for, because if not, they might not do the math, not because they don't understand the math, but because they don't understand the context. Option 2. Plan with your lowest and highest students in mind using thought bubbles and extensions. We're going to look at that same word problem. So my thought bubbles are used for my students who have a tough time getting started. I'll put them right on the smartboard with the question so all students can see it, but not all students need it. An example is, will the combined measure be less than or greater than 28/100ths of a meter? That way, students that are having trouble getting started, they can pick greater than or less than without needing to be accurate. That way you can see if they are understanding what the problem is asking at all. Are they just having trouble with the addition, the multiplication? This was an addition problem, and multiplication was kind of a way for students to push their thinking a little bit further. What would be the combined measure if each tube was 1 meter long? I love this thought bubble because it takes away the decimal, which is a little scary for students, especially fractions, problem with fractions. If you throw in a whole number, students might be able to know what operation to do or how they're going to solve the problem. They can apply that thinking to the decimal or the fraction. Can I draw a diagram to represent the connected tubes? Now, this kind of goes hand in hand with the first one. If you didn't show them how to stack the cardboard tubes, maybe they want to draw that so they can picture it before they choose a way to tackle this problem. Now, for my higher students, I include extensions. And this can be a student that is considered higher at any day of the week, depending on the lesson. So the first extension, how would your answer change if Maxine was connecting 5 tubes, 6 tubes, 10 tubes? This is how we're going to push them from addition to multiplication of decimals. Extension 2, how would your answer change if each tube was 1/1400th meter long? And extension 3, how many cardboard tubes would Maxine need if she wanted a combined measure of 1.96 meters? So these students can get to at any point in time while everybody's working. That way, if they're done early, they're not going to shout out, "Oh, I'm finished, miss, I'm done. What do I do now?" That gives everybody time to continue working. Option 3, allow students to choose the values. This is one of my favorite strategies. So back at the same word problem. Let's rewrite it. And as soon as you do this a few times, it is not as hard as it seems, and it doesn't take that long. So this is the new one. You are making a model windmill for a science fair by vertically connecting cardboard tubes. Each tube is 28/100ths of a meter in length. How many cardboard tubes will you connect? What is the combined measure of the connected tubes? So now first, right off the bat, you're saying you're putting the students in the situation, which immediately gets them a little bit more engaged. Additionally, you're asking them to decide how many tubes they're connecting. So they can say 2 and just add them together. They can say 5 and multiply them. They can choose as many as they want, and then they find the combined measure. A great part about this strategy as well is that if you have a student that says, well, I'm going to connect only 1, so it's 28/100ths of a meter in length, you can talk to them individually and push them a little bit further. Knowing your students, you can give them some suggestions on a number of cardboard tubes. So let's review. Differentiation is providing multiple paths for students to master the same content. Differentiation is not limiting some students to easier work while only exposing some to a challenge. And 3 ways to differentiate are to add pictures, plan with your lowest and highest students in mind with thought bubbles and extensions, and allow students to choose the values. I hope you enjoyed this crash course on differentiation. If you have any questions or you want to share how you differentiate your math word problems, be sure to comment below.